Hello, today we're going to take a look at some conversions between the different metric prefixes. And this list appears in your notes online that are available. It also appears in your book. These are, I think, the main prefixes you're going to need to know: kilo, deci, centi, milli, micro. You should know what the symbols are, and you should know what they stand for. We should know how many of each prefix unit is equivalent to how many base units. In the notes available online, you'll notice that I've used B's instead of X's. That's representing whatever the base unit is. So if I'm measuring masses, the base unit would be G for grams. If I'm measuring length, the base unit would be M for meters. If I'm measuring the volume, the base unit might be L for liters, and so forth and so on. So these relationships we're going to need to know. Unlike in the English system where I have gallons and then other volume measurements would be we've got 4 quarts to a gallon, and then we've got 2 pints per quart, and then we've got 2 cups per pint, and then we've got 8 ounces per cup. This is a very uniform way of dealing with different sizes of units, no matter if we're measuring mass or length or whatever. So that's why we're going to be using metric, because the whole science community does. So let's talk about converting units. My method, which is the method you'll see in your book, which is the method I'm going to use all year long, it's what all the other scientists are doing, is called, you might hear it referred to as the factor label method or as dimensional analysis. When we get into multi-step problems, this is a very useful way of dealing with the multiple steps and keeping track of the correct units. But this is also, if you do it correctly, a great way to make sure that you're always multiplying or dividing when you're supposed to. So sometimes for if I convert between 2 numbers, they're not sure if they're multiplying or dividing by the 100 or the 1000. So this is going to help us make sure we get everything in the right place. If you want to do it a different way, as long as it works 100% correctly and you can show me your work and I can figure out what you did, then you can use a different way. So the idea is we're going to take a conversion factor with one of these relationships, and the conversion factor is going to be a fraction. So one of the numbers in the equivalence is going to go on the top of the fraction, one will go on the bottom, and then we'll use that to convert the units on our original number. So let's take a number, 585,000, and let's say that's micrometers, and we want to know how many meters that's equivalent to. So micrometers and meters. The first thing I would do is look for the relationship between those 2 units. So notice the micro, that's this little Greek symbol mu, there it is there. So there's 1 million of the micro unit equal to 1 of the base units. Now I'm not going to put the X's in or the B's in that you see online in the notes. I want to put whatever the actual unit is, so make sure that you're substituting in. This is just kind of a generic stand-in for my table. So 1 million micrometers equals 1 meter. It's very important that even if you have 1 million memorized as the micro amount, that you know that that goes with the micrometer, the one with the prefix on it. Okay, so the idea is we're going to take these numbers, we're going to put them into a conversion factor. Conversion factor is one on the top, one of these numbers on the top, and one on the bottom. And how we decide which goes on the top or the bottom is going to depend on what units we're given to start with and what units we want to end up with. So I have 585,000. So to set up, I'm going to write that down with the unit. So you guys who like to just not put on units because you don't feel like it, write them down. It will help you set up your problem. That number that's given in the problem always goes first. It never ever goes into the conversion factor, ever. So that's very important. And then that's going to be times something. So this is a time sign. This is not an equal sign. Mathematically speaking, how we treat an equal sign versus a time sign, that's very different. So then I'm going to put a fraction. So here's my big line I'm going to make a fraction out of. I'm going to put one of these numbers on top from the equivalence and one on the bottom. So I want to get units of meters. So the unit and number from the equivalence that has the unit I want, that goes on the top. So I put the 1 meter on the top. On the bottom, I'm going to put this other one. Now, the idea here is that we know about fractions. Like if I have a common factor in the numerator and denominator of a fraction, that common factor will cancel out. So the same can be done with units, where I see micrometer here, and it's on the bottom. This will cancel out with this, right? So we can kind of, if you can't see it, you can visualize this over a 1. That helps you visualize it as a fraction. So the same in the numerator and denominator is going to cancel out. That's why we're doing it that way, so that we can see these two are going to cancel out, so I want to divide by the 1 million. All right, so this is multiplication. So for fractions, we multiply the tops of fractions. So whatever's here times the top of my conversion factor, and then we're dividing by the bottom. So times the numerator, divide by the denominator. Times the top, divided by the bottom. So this is 585,000 times 1. If you don't want to type that in your calculator, that's fine. You know that 585,000 times 1 is 585,000, but then we're dividing by the 1 million. And so that comes out to be 0.585, and then that would be meters. Now, significant figures. My original measured value has 1, 2, 3 significant figures. Again, these trailing zeros don't count because they're placeholders. There's no decimal point. My converted number should have the same number of significant figures. So these are considered exact values. There's exactly 1 meter in 1 million micrometers, or vice versa. So these are not going to limit or affect our significant figures because these aren't measured values. This is the measured value, and so that has 3 digits. This gets 3. Remember, this leading zero doesn't count until we get to the first non-zero. So that's 3 significant figures also. All right, let's try another one of these. Now let's do something besides metric. So some of you probably are thinking you can do this in your head, or you can learn the method where you just move the decimal point. Okay, fine, as long as you know these relationships, you can show me how you got it. Okay, so be it, as long as it works. But sometimes we have numbers that we don't have the relationships, not like a factor of 10. So, for instance, there are 2.54 centimeters equal to 1 inch. Right? And I know that there are, well, start with that. Okay, so let's say I want to convert 582 centimeters, and I want to convert that to inches. Okay, so I want to know how many centimeters 582 is in inches. So my relationship, I've already got that written down for me. If you didn't have that written down by me ahead of time, what you could do is go look it up and then write it down somewhere so you have it. I don't know if you can see that in the video, but it says 2.54 centimeters equals 1 inch. So start by setting up your problem, original number with units, and then a time sign, and then I make my fraction line, and then I'm going to put, let's see, the unit I want goes on the top, so I want to end up with inches. So from this relationship, that's where these numbers that go with the conversion factor coming from. 1 inch goes on the top. The number with the unit I want to cancel out goes on the bottom. So the 2.54 that came with the centimeter unit in the relationship, that goes on the bottom. And so notice here's a centimeter, and in the opposite, so on the bottom of the fraction, there's a centimeter, those will cancel. So it's 582 times 1 divided by 2.54. And let's see, what does that come out to be? 2.54. So lots of numbers on my calculator, but I know better than to write them all down. This has 3 significant figures, so that means that I'm allowed to write down 3 significant figures. So this, I would write down 229, write down my unit, and there we go. Okay, so this method works no matter which units I'm converting between, as long as I have this equivalency. So this many of this equals this many of this. When we get into multi-step problems, this is a great way to keep track of our units. And again, to make sure I know if I'm multiplying or dividing by, the 2.54. Some people like to use proportions, and that works if you do them correctly, and I'm not trying to ruin what you know how to do. But if your method does not 100% work all the time, however you're setting them up, then maybe try the way that, again, once you learn how to do it correctly, it will always consistently work, always get us the right answer, and it gets us the right setup. This is not the same thing as cross multiplication, so I'm not, it's not the same thing as putting 2 fractions equal to each other and cross multiplying. That's not what this is. This is numerator times numerator divided by denominator. So that's how this is getting solved. That's how I got this number out. And we'll do more of these in class for practice.